I hope you are healthy and doing all well. So we're going to start from where we have left in video number 2, and now we will going to discuss in detail where we have left over earlier video. So in earlier video what we have seen, we have completed up to the point the force equation we have already discovered, and those who have not knowing about this they can check the previous video. So f is equal to kx, where we have approach and where we have reached on earlier occasion. Now let me quickly tell you about, like, f is equal to ma is equal to minus ax. So from there we can say upon m into x. Clear? So this k upon m, let's take as omega square. This is the trick through which you can able to get all type of time period very easily. So this is the assumption, like k upon m we have always considered as omega square, so ultimately it will turn to minus omega square into x. Since if omega is constant, we can say acceleration is directly proportional to negative of x. This is the one of the point to which we can say the given motion is a type of SHM. Clear? Now let's quickly draw a graph and let's compare it with pendulum motion. Fine. Here we can say the both from the mean, let's say the displacement would be x, and maximum displacement for the time being, let's consider the given SHM by one notation. Let me quickly tell you. Here we can say, like, pendulum executing its motion for first quarter, let's say point start from point number 1 to 2, and this is extrema, and once it will once again return back to the mean position, we can say point reach from 2 to 3, and once again go to the next end to 3 to 4, and once again return back to original 4 to 1. So basically these point executing circular motion. But what about the normal? If you draw on the given axis, look at the normals. Rather we say normal, we can say this is perpendicular, because normal we can come across in only 3D surface. So what about the normal? We can say normal from 1 to 2, the point executing on circumference, but normal executing along the line, and from 2 to 3 it will once again downward, 3 to 4 downward, 4 to 1 upward. So it look like the normal is executing SHM, where the point executing circular motion. So always remember, whenever we are just going to calculate any uh, physical parameter like velocity, displacement too, we will use this fact. The point is executing circular motion, whereas the normal onto it is executing simple harmonic motion. So maximum, let's say the circle having a radius a, so what maximum it can go, and here we have seen either of the side the particle executing its amplitude. Let's say x is variable and maximum value of x would be a is radius of the given circle and also called as amplitude. Maximum x, it would be a, that is amplitude, and this is basically the radius of the given reference circle. Clear? So by considering this motion, let's quickly, because this is the area that was asked earlier as well, so this is not very visible. Let's take, so here we can say the maximum value is a on either side, and in between if we are picking, we can say that would be x. Clear? So once the particle is at the highest point, let's say highest point, this is the highest point. So when the particle is at the highest point, correct, in the highest point, so at this point always remember the velocity would be 0 and a should be max. A stand for acceleration. When the particle having journey from extreme position towards the mean position, this is a mean position. So when the particle executing journey from extreme position to mean position, what will happen? We can say acceleration is decreasing because it is a maximum value, and velocity is increasing. Always because velocity is 0. Once the particle reach at this point, here we can say v should be max. And what about a? A should be 0. And once again the particle further go to its next extrema, once again velocity will turn to 0 and acceleration would be maximum. Clear? And similarly, when it will going to again towards the same thing happen, acceleration decreases, velocity increases, velocity will maximum at this position, and here we can say acceleration increasing and velocity decreasing. So these are the 4 coordinates through which we can quickly analyze one, 2, 3, 4. Under these situations, you better to remember what will happen to the first half, second half, third half, and fourth half. Clear? So, and always remember, when the acceleration and velocity will be 0 and at the extreme position, this is the mean position, quotient is there, once again extreme. So extreme, mean, extreme, because this piece of information they might be asked in any ways. So this is all about I repeat once again, we have already derived the equation y is equal to fx, where we have seen the acceleration, and here I have considered k upon m as omega square. So ultimately the equation turned out to be acceleration is equal to minus omega square x, where omega is equal to constant. So we can say a is directly proportional to negative of x. X is basically, we can say, displacement, and the max value of it will be a. A is amplitude, or we can say radius of the given circle. And here we have seen how the acceleration and velocity got variation, how velocity and acceleration got vary. And I have compared the pendulum motion with one of the reference circle equation, where we have seen the particle executing circular motion and the perpendicular executing the simple harmonic. Here rather normal, we can say perpendicular, because normal is not a correct term. So let me remove it. This is not a correct term, rather perpendicular should be the correct term. Fine. And then what we have seen, the circle, the radius and the maximum displacement is called a, and a is called amplitude, or we can say radius of the given circle. So this is all about in this given case. Now next occasion we will going to discuss about few kinematic equation, like we will see xt graph, vt graph, at graph, and xv, av, and ax. So once you will derive these 6 equation, there's so many question it was asked previous years regarding the graph and regarding the shape. And if you are very good in kinematics, you can easily derive those equation. Maybe you have already done in variable acceleration case or variable motion, you have already derived those equation in kinematics. But specifically this notation we will surely see in the next video. Till then, take care, keep revising, because it's very less days to go for your given goal and given target. Have a nice time. Take care.